In a surprising turn of events, Kawasaki, widely known for its iconic green motorcycles, has taken a bold step beyond two wheels. The Japanese manufacturer recently introduced a new concept vehicle called Corleo, a machine designed not only to traverse all terrains, but also to redefine the very idea of mobility.
Everyone knows that Tesla as a brand is always pushing itself to create vehicles that look like something straight out of a science fiction movie. This time, the company is taking things a step further by creating a new hydrogen-powered robot that might just change the transportation industry as we know it. This robot is said to be faster and more eco-friendly than anything the world has ever seen before. So what exactly makes this robot so groundbreaking? And does it truly have what it takes to disrupt the auto industry? Stay tuned, because what you're about to discover is sure to blow your mind. The revolutionary design of the hydrogen-fueled robotic vehicles. Tesla is working on entering the hydrogen-powered industry, especially since the world is starting to move past the need for regular electric vehicles or EVs. While the company hasn't officially put out the vehicle model yet, there are several rumors implying that it is already a work in progress. Now, in a world where robots are often imagined as stiff, mechanical, and sometimes even clumsy, a prime example of these robots, like the Corleo robot from Kawasaki, gallops in like something out of science fiction.
Kawasaki unveiled Corleo, a two-seater robotic horse, at the Osaka Kansai Expo preview.
But grounded firmly in incredible engineering as it is fueled by hydrogen. Apart from the fact that it's powered by hydrogen, what exactly is so special about this robot? Well, at first glance, it is impossible to ignore how different these vehicles look from what we've come to expect of a robot. It doesn't roll on wheels, nor does it glide like a drone. Instead, it moves with purpose, with strength, and with an almost eerie grace that's been inspired by the animal kingdom. The design of these robots is revolutionary, not only in what it looks like, but in what it does and means for the future of mobility. These robots defy easy categorization. Is it a vehicle? Is it a robot? The answer is both and neither, really. It stands at the crossroads of two major disciplines, robotics and transportation. This hybrid identity allows it to do things that traditional cars and robots can't. It challenges the rigid lines that have long divided machines with wheels from machines with legs. These robots redefine mobility. Where conventional vehicles get stuck in mud or snow or rocky terrain, these robots walk forward confidently, their legs adjusting to the uneven surfaces beneath them like a living creature. It doesn't just move through the world, it adapts to it. And in doing so, it invites us to imagine a future where machines don't just operate within environments, they belong to them. One of the most striking elements of these robots' design is that it takes inspiration from animals, specifically the horse. Its legs bend and stretch with surprising flexibility, mimicking the gait of a galloping steed. When you watch it move, there's a natural rhythm to it, and it almost looks like watching a powerful animal stride through the wild. These robots can leap, climb, and even sidestep obstacles that would stop traditional machines in their tracks. This animal-inspired mobility is not just clever, it's brilliant. It opens up an entirely new category of robotic design, one that prioritizes agility, awareness, and physical intelligence. The legs of these robots are probably its most iconic feature. 4 powerful limbs, each engineered with precision, allow the robot to balance, pivot, and adjust on the fly.
Corleo, which is a 4-legged robot that's powered by hydrogen and equipped with artificial intelligence.
These legs give these robots not just strength, but intelligence. They sense the ground, gauge terrain changes, and respond accordingly. At the bottom of each leg are specially engineered hooves, not hard, clunky feet, but adaptive pads that respond to the surface beneath them. Whether it's snow, gravel, grass, or loose sand, these hooves grip, flex, and stabilize. They act almost like a combination of a paw and a tire, giving these robots traction where it needs it most. What's even more fascinating is how smoothly those legs move. These robots don't stomp, they glide. Thanks to an advanced suspension system that works alongside its leg joints, the robot absorbs shock like a luxury vehicle. Each step is cushioned. Each motion is balanced. The suspension doesn't just protect the machine, it enhances its ability to mimic the fluidity of a living animal. There's an elegance to the way it navigates uneven paths, adjusting each joint and hoof with surgical precision. This level of mechanical harmony is rare, especially in machines that are meant for hard work. But these robots prove you don't have to sacrifice grace to gain strength. Things don't end there. Under all that graceful movement is serious engineering. These robots can travel up to 150 miles on a single hydrogen charge, and because it uses hydrogen, it refuels faster than electric vehicles, which gives it another edge in real-world performance. This machine isn't just for labs or tech expos. It's being built for the wild, for work, for the unexpected. You could imagine it getting around mountains, forests, deserts, even post-disaster zones where no ordinary car could go. It's an answer to questions we haven't even fully asked yet. What kind of robot can go where humans can't? What kind of vehicle can act like an animal, feel the ground, and respond in real time? At its heart, these robots are about one powerful idea: that robotics doesn't have to be cold, boxy, and mechanical. It can be alive in its own way. It can learn from nature, walk through it, and even protect it. This robot doesn't just do something new, it means something new. It represents a shift in how we see machines, not as tools, but as companions, as co-travelers in the world we love and live in. With its revolutionary design, these robots challenge everything we thought we knew about vehicles, robots, and mobility. But what about its fuel? Why was hydrogen specifically to fuel this work of innovation? Keep watching, because what you're not prepared for, what we're about to reveal. Why the hydrogen makes a great fuel for robotic vehicles. The world has been steadily falling in love with electric vehicles, especially since they represent a future defined by quiet roads, clean air, and the comforting glow of charging stations.
Electric vehicles, all the rage, very popular here in the Valley. California has a law requiring electric-only car sales by 2035.
Battery electric vehicles have found their place in cities, suburbs, and on highways. But as the world grows less predictable, the roads more rugged, and the urgency of mobility more immediate, electric power begins to show its limitations. This is exactly why robotic vehicles are created, and why hydrogen fuel makes it a uniquely capable machine for real-world applications. For example, Kawasaki's Corleo robot's use of hydrogen fuel is more than a technical choice. It is a declaration of purpose. Unlike conventional battery electric vehicles that rely on long charging times and access to stable infrastructure, Corleo is powered by a hydrogen fuel cell that produces electricity on demand, emitting nothing but water vapor. This simple, elegant reaction between hydrogen and oxygen enables Corleo to function efficiently and cleanly, even in remote or unstable environments where electric charging stations are non-existent. That's not all. Hydrogen's advantage lies in both its speed and density. Refueling these hydrogen-based vehicles takes mere minutes, which can be compared to filling a tank with gasoline. This is a huge contrast to electric vehicles, which usually require hours to recharge, especially in areas lacking fast-charging technology. In time-sensitive situations, whether in agriculture, logistics, or emergency response, this speed is very important. These hydrogen-based vehicles can cover approximately 150 miles on a single tank, and with its compact hydrogen system, that range does not come at the cost of agility or weight distribution. From an energy perspective, hydrogen holds another huge advantage, and that is energy density. Pound for pound, hydrogen stores even more energy than even the most advanced lithium-ion batteries. For these vehicles, this means more power delivered over longer distances without the need to sacrifice space for massive battery packs. It also means fewer limitations imposed by temperature extremes, which is a common issue with traditional electric vehicles, whose batteries tend to underperform in cold or overly hot conditions. Hydrogen systems, by contrast, are far stronger in diverse climates, which reinforces these vehicles' real-world readiness even more. In practice, these technical qualities translate into a versatile and responsive machine, one that can move through environments where wheeled vehicles cannot. Consider the implications for agriculture. In rural, mountainous, or marshy regions where farming often requires access to fields far removed from paved roads, these vehicles' legged mobility and hydrogen power system combine to create a tool that can operate independently of traditional infrastructure. With the ability to traverse uneven ground, carry tools or sensors, and return quickly for refueling, it opens new possibilities for sustainable farming and monitoring. The same is true in the field of logistics. Traditional delivery vehicles are limited by terrain, road conditions, and fuel supply chains. These vehicles' lightweight yet powerful hydrogen system enables it to serve as a mobile cargo platform, especially in last-mile scenarios where rough ground or natural obstacles render trucks ineffective. In remote areas, particularly in regions undergoing development or disaster recovery, this capability can mean the difference between access and isolation. In the tourism industry, hydrogen allows these vehicles to carry guests or guides through landscapes too sensitive or rough for vehicles with heavy emissions or loud engines. The silence of its powertrain allows travelers to experience nature without disturbing it. Its emissions, pure water vapor, mean it leaves no ecological trace. This aligns with the growing global emphasis on ecotourism and responsible travel. Yet what is probably the most compelling use case for these vehicles' hydrogen-powered design lies in disaster response. When earthquakes, floods, or landslides strike, infrastructure is often the first thing to collapse.
Aerial view of a collapsed Route 30 in East Pittsburgh. This video here from within the last half hour. All of this caused by a landslide.
Roads may become impassable, power grids may fail, communication lines may be cut. In such environments, the ability to deploy a mobile unit like these vehicles, one that doesn't rely on electricity from the grid, can carry aid or communication equipment and get through broken or unstable ground, becomes not only useful, but vital. These vehicles can function as a scout, a transport vehicle, or even a mobile supply unit in these situations. Its ability to move independently and maintain long operational hours without the need for recharging allows first responders to extend their reach. Moreover, the safety and environmental profile of hydrogen fuel makes it a viable option for deployment in sensitive or volatile settings. Still, hydrogen fuel technology is not without its challenges. The current infrastructure to support widespread hydrogen refueling is limited, particularly outside of regions like Japan, Germany, or California. Public perception remains cautious, often shaped by outdated concerns over hydrogen's volatility or storage requirements. Companies like Tesla that intend to make these robots, therefore, face not just an engineering challenge, but a narrative one, to change the global conversation and demonstrate hydrogen's reliability, safety, and long-term potential, especially in the robotics sector. Vehicles like Corleo, however, are ideal ambassadors for this shift. It embodies the benefits of hydrogen in a form that is practical, visible, and dynamic. Its movement, fueled by clean and efficient energy, offers a tangible glimpse into what hydrogen-powered mobility can achieve beyond the highway. By proving that hydrogen fuel cells are not just theoretical alternatives but functional, powerful engines for real machines in real situations, Corleo gives weight to Kawasaki's argument for hydrogen's future. Now, we have established that these vehicles are incredible by every regard, but are there any challenges that could prevent this work of innovation from reaching great heights? Stick around to find out. Challenges associated with these robots. As with any cutting-edge technology, these robots' journey from prototype to mass production is not without its challenges. For one, taking these vehicles from a prototype to mass production is no easy task. The robot is a complex machine, designed to get through rough terrains with precision and agility, all while running on hydrogen fuel cells. This means that scaling up production requires not just the ability to mass produce the robot's parts, but also maintaining the high quality and functionality that made the prototype successful. One of the first challenges these companies will face is ensuring that the high-quality materials used in the robot's design remain consistent when scaled up. Components like these vehicles' custom-made legs, the hydrogen-powered engine, and the intricate sensors are all carefully crafted to work in harmony, giving the robot its unique capabilities. The challenge here lies in keeping these components precisely engineered as production increases. Any slight deviation from the prototype could risk compromising these vehicles' performance. Moreover, mass production will require huge investment in new manufacturing processes and supply chains. Each part of the robot needs to be sourced from reliable suppliers, and these companies must establish these supply chains while ensuring that the production process is cost-effective. Scaling up without sacrificing quality will be a delicate balance for the company. While these companies' focus is on creating a hydrogen-powered robot, Tesla is not the only company aiming to revolutionize robotic mobility.
Tesla announced a plan that involves the development and launch of many new products in the next 2 years. And while it's not yet certain that Optimus humanoid robots will hit the assembly line in Austin next year,
Boston Dynamics, with its quadrupedal robot Spot, has gained huge attention in the robotic mobility space. Spot's ability to move over rough terrain has already made it a popular choice for industrial use, and while it isn't powered by hydrogen, it has set a high bar in terms of performance. These companies will need to show that these vehicles are a superior alternative in terms of both mobility and energy efficiency. The challenge is not just competing with Boston Dynamics, but also convincing the market that hydrogen-powered robots offer distinct advantages over the technologies that are already well established. In this landscape, these companies' challenge lies in proving that these vehicles' unique design and hydrogen fuel system are what set it apart, especially as other companies are also pushing forward in robotics. Now, we mentioned earlier in this video that at the heart of these vehicles' innovation is its hydrogen-powered system, which sets it apart from the EV and robotics market. However, hydrogen-powered vehicles, including robots, face a huge challenge, which is that EVs have already dominated the consumer market and are increasingly being adopted for various industrial applications. In the world of consumer vehicles, companies like Toyota and Honda and even Kawasaki have been focusing heavily on hydrogen technology, though primarily for passenger cars. Their experience in hydrogen production could pose a threat to these vehicles if they decide to expand into the robotics space. The widespread adoption of EVs could also make it harder for these companies to convince consumers and industries to embrace hydrogen fuel cells, especially if EV infrastructure is more established. These companies must prove that hydrogen-powered robots like these vehicles are more suited to certain applications, like long-distance mobility and rough terrain operations. In order to stand out, these companies must show that hydrogen has a clear advantage over electric power when it comes to the type of mobility these vehicles provide. Wait, there's more. It's not just robotics companies that these companies have to worry about. Major tech companies like Amazon and Google are investing heavily in robotics, automation, and artificial intelligence. While these tech giants haven't yet released robots comparable to these vehicles, their involvement in the field and rapid pace of innovation means that these companies must stay ahead of the curve. Amazon has already integrated robots into its warehouses for inventory management, and Google's autonomous vehicle technology continues to progress. If these companies decide to enter the market for mobile robots that can get through difficult terrain, these companies could find themselves competing with organizations that have vast financial resources and technological expertise. Despite the competition, these vehicles have the potential to revolutionize several industries. Its ability to navigate rough terrain and operate in environments where traditional vehicles struggle makes it an ideal solution for sectors like logistics, agriculture, and disaster response. For logistics, these vehicles could operate in areas where trucks and other vehicles can't go, like remote or rugged terrains. In agriculture, it could be used for tasks like monitoring crops, planting seeds, or even harvesting in places where human workers or machinery might not be able to access. And in disaster relief, these vehicles could prove invaluable by transporting aid or rescuing people from areas that would be impossible for traditional vehicles to reach. These vehicles' advanced design also requires to bring vehicles like Corleo to market. These companies will need to find ways to reduce these production costs. That could mean simplifying certain aspects of the robot's design, finding more cost-effective suppliers, or investing in manufacturing processes that allow for greater scalability. If these companies can figure out how to lower the costs while maintaining the robot's advanced features, it will be in a stronger position to compete. Finally, these vehicles face the challenge of public perception. Robots, especially autonomous ones, often evoke skepticism and fear. Many people are unsure about trusting a robot to perform tasks that require precision and responsibility, particularly in critical applications like disaster relief or agriculture. These companies will need to educate the public about the benefits of these vehicles and how it can improve industries that require mobility in difficult environments. Trust will play a significant role in these vehicles' success. Public education and demonstrating the robot's reliability and safety will be key to overcoming these challenges. While these robots are a groundbreaking leap in robotics, it faces several huge challenges on its path to mass adoption. From scaling production and managing costs, to navigating competition from other tech giants and addressing infrastructure needs, these companies have their work cut out. But if the company can overcome these obstacles, these vehicles could change the way industries approach mobility, paving the way for a new generation of robots capable of tackling some of the world's toughest challenges. So, what do you think about these hydrogen-based vehicles? Do you believe that Tesla has what it takes to tap into this potentially lucrative market? Let us know in the comment section. Remember to like, share, and subscribe for more. Also, click the following video shown on your screen. You will enjoy it.